Right now, our entire galaxy, along with every star, every planet, and everything you have ever known, is hurtling through space at more than 1.3 million miles per hour, being dragged toward something scientists cannot see, cannot photograph, and cannot fully explain. It is not a black hole. It is not a single object. It is a region of space so massive that it is pulling on us from more than 200 million light years away, and for decades, our own galaxy sat directly behind it, hiding it from our view. Astronomers gave it a name that sounds like science fiction but is entirely real. They call it the Great Attractor. Tonight, we are going to explain exactly what it is, how we found it, and why it remains one of the strangest unsolved mysteries in modern cosmology. My name does not matter for the next hour. What matters is that you stay with me, because by the end of this video, you will understand a force shaping the motion of our entire galaxy, one that most people have never even heard of. Let us start with something that surprises almost everyone the first time they hear it. Galaxies are not standing still. The universe itself is expanding, and every galaxy is being carried outward from every other galaxy as space stretches between them. This is called the Hubble flow, and it means that, on average, the farther away a galaxy is from us, the faster it should appear to be moving away. This is one of the most well-established facts in all of astronomy. But in the 1970s and 1980s, astronomers began noticing something that did not fit this simple picture at all. When they measured the velocities of galaxies in our region of the universe, the numbers did not line up cleanly with the expected expansion of space. Some galaxies were moving faster than expected. Others were moving in directions that suggested they were being pulled sideways, off the clean, straight path that the expanding universe alone should have produced. Our own galaxy, the Milky Way, along with our entire local group of galaxies, appeared to be drifting through space at an extraordinary speed, far greater than the expansion of the universe alone could explain. Something massive, somewhere, was tugging at us gravitationally, and it was not something anyone had mapped or measured before. This mysterious motion is called our peculiar velocity, the velocity a galaxy has beyond the simple stretching of space caused by cosmic expansion. And when astronomers began calculating just how fast the Milky Way and its surrounding galaxies were moving due to this unexplained pull, the number was staggering. We are being pulled towards something at roughly 1.3 million miles per hour, a speed almost impossible to comprehend, fast enough to cross the entire diameter of the Earth in under 20 seconds. So naturally, astronomers wanted to know one simple question: what exactly is pulling us? This is where the story becomes genuinely fascinating, because the answer to that question was hidden by one of the most frustrating obstacles in observational astronomy, our own galaxy. The Milky Way is a flat, disc-shaped galaxy, and we are located inside it, roughly 2/3 of the way out from the center. When we look toward the plane of our own galaxy, our view of anything beyond it is blocked by an enormous wall of stars, gas, and thick interstellar dust. Astronomers call this obscured region the zone of avoidance, and by cruel cosmic coincidence, the direction of this mysterious gravitational pull happened to line up almost exactly with this hidden region, directly behind the crowded core of our own galaxy. For years, astronomers knew something massive was out there pulling on us, but they could not see it directly, because our own galaxy was standing in the way like a curtain blocking the stage. It took entirely new observational techniques, ones that could see through galactic dust, to finally begin mapping what lay hidden behind the veil. Astronomers turned to infrared and radio astronomy, wavelengths of light that can pass through interstellar dust far more easily than visible light can. Using infrared surveys conducted throughout the 1980s and 1990s, and later refined with radio telescope surveys specifically designed to peer through the zone of avoidance, scientists slowly began mapping thousands of previously hidden galaxies directly behind the Milky Way's dusty plain. What they found was staggering in scale. A massive concentration of galaxies, later named the Norma Cluster, sitting at the approximate center of this gravitational pull, roughly 250 million light-years away from Earth. But here is where things become even stranger, because the Norma cluster, despite being genuinely massive, still did not appear to have enough mass on its own to account for the full gravitational pull scientists were measuring. Something even larger was needed to explain the sheer scale of the attraction. This led astronomers to a much bigger discovery. The Great Attractor was not simply one cluster of galaxies. It appeared to be part of an even more enormous structure, a vast supercluster of galaxies that dwarfed almost anything previously mapped in the nearby universe. In 2014, an international team of astronomers led by R. Brent Tully used detailed measurements of galaxy velocities across an enormous region of space to map the boundaries of this structure for the first time. What they revealed was breathtaking. Our Milky Way, our local group, the Great Attractor, and the massive Norma cluster were all part of an even larger cosmic structure, a colossal supercluster of galaxies spanning roughly 500 million light-years across, containing the mass of approximately 100,000 galaxies like our own. They named this vast structure Laniakea, a Hawaiian word meaning immense heaven, chosen specifically because Polynesian navigators once used the stars to guide their journeys across the vast Pacific Ocean, just as astronomers were now using the motion of galaxies to map our place within an unimaginably vast cosmic ocean of space. Laniakea reshaped our entire understanding of where we sit in the universe. For most of the 20th century, astronomers believed the Milky Way belonged to a relatively modest supercluster called the Virgo Supercluster. The Laniakea mapping revealed that the Virgo Supercluster was not an independent structure at all. It was merely one small lobe of an enormous cosmic basin, all being gravitationally funneled toward the same central point, the Great Attractor, sitting at the gravitational heart of Laniakea like the drain of an unimaginably vast cosmic basin. Picture it this way. Imagine an enormous, gently sloping valley, so large that entire mountain ranges are actually mounds within it, and every drop of water within that valley slowly flows downhill toward one central point. That is essentially what Laniakea looks like on a cosmic scale, except instead of water, it is galaxies, and instead of gravity pulling water downhill, it is the combined gravitational mass of the entire supercluster, pulling every galaxy within it slowly toward the Great Attractor at its gravitational center. Now, an important clarification, because this point causes confusion even among people who have heard of the Great Attractor before. We are not going to crash into it. The expansion of the universe itself is accelerating, driven by the mysterious force known as dark energy, and on the largest scales, this expansion is winning against the gravitational pull of Laniakea. Current research actually suggests that Laniakea itself may not remain a permanently bound structure at all. Over unimaginably long timescales, the accelerating expansion of the universe may eventually overpower the gravitational pull holding Laniakea together, gradually pulling even this colossal supercluster apart, galaxy by galaxy, into the widening darkness between them. But on the timescales relevant to us right now, the pull toward the Great Attractor remains a real, measurable, and genuinely mysterious force acting on our galaxy. And there is an additional twist to this story that took astronomers even longer to fully unravel. As radio telescopes eventually mapped in even greater detail beyond the immediate region of the Great Attractor, they discovered something even more massive lurking farther away, an enormous concentration of galaxy clusters known as the Shapley Supercluster, sitting roughly 650 million light-years from Earth. The Shapley Supercluster is now believed to be the single largest concentration of galaxies in our observable local universe, and its gravitational influence may actually be helping pull the entire Laniakea supercluster, including the Great Attractor itself, toward it, like a smaller whirlpool caught in the current of an even larger one. this raises a genuinely mind-bending possibility. The Great Attractor may not be the ultimate destination of our galaxy's motion at all. It may simply be the nearest, most locally dominant knot of mass in an almost incomprehensibly vast hierarchy of gravitational structures, each one nested within an even larger one, stretching out in a cosmic hierarchy far beyond what any single map has yet captured. So what exactly makes up the Great Attractor itself? At its most fundamental level, it is simply an extraordinarily dense concentration of galaxies, galaxy clusters, hot intergalactic gas, and based on everything we have learned about the universe's total mass budget, an enormous amount of dark matter, the same invisible substance responsible for holding individual galaxies together, here operating on a scale that defies easy comprehension. The combined visible and invisible mass of the Great Attractor region is estimated to be equivalent to many thousands of trillions of times the mass of our Sun, an amount of gravitational influence so enormous that it measurably alters the trajectory of galaxies located hundreds of millions of light years away. The story of the Great Attractor is, in many ways, a story about the limits of human observation and the persistence required to overcome them. For nearly 2 decades, astronomers knew something enormous was out there purely through indirect evidence: the peculiar velocities of galaxies, the subtle deviations from the expected expansion of the universe, without being able to directly see the thing responsible. It took entirely new observational tools, infrared astronomy and radio astronomy capable of piercing through the obscuring dust of our own galaxy, to finally reveal what had been hiding in plain sight the entire time, directly behind the crowded, glowing disk of the Milky Way itself. There is something genuinely humbling about this discovery. We often imagine that astronomers can simply point a telescope anywhere in the sky and see everything there is to see. The truth is far more complicated. Roughly 20% of the sky, the region obscured by our own galaxy's disk, remained essentially a blind spot in astronomical mapping for most of the 20th century, and hidden within that blind spot was one of the most massive gravitational structures ever discovered in our cosmic neighborhood. Today, astronomers continue refining their maps of Laniakea and the Great Attractor using increasingly sensitive radio and infrared surveys, along with new techniques that measure the subtle gravitational effects of large-scale structure on the cosmic microwave background itself. Each new survey adds detail to the map, revealing finer structures within the supercluster, refining our understanding of exactly how much mass is concentrated where, and helping astronomers understand not just where we are being pulled, but how typical or atypical our own cosmic neighborhood truly is compared to the rest of the observable universe. Think about what this means the next time you look up at the night sky. Every star you can see, every galaxy captured in even the most powerful telescope images, exists within a vast, invisible current of gravity, flowing across hundreds of millions of light years, funneling entire galaxies toward a single, massive concentration of matter that remained completely hidden from human eyes until just a few decades ago. Our galaxy, our solar system, our planet, all of it is being carried along in this vast cosmic river, moving at more than 1 million miles per hour toward a destination we can now finally see, hidden just behind the light of our own galactic home. We are not simply floating in empty space. We are caught in the gravitational current of an unimaginably vast supercluster, being pulled toward the beating gravitational heart of our cosmic neighborhood, itself possibly being pulled toward something even larger still. The universe, it turns out, is not just expanding uniformly in every direction. It is flowing, gathering, and organizing itself into rivers and valleys of gravity, on a scale that took humanity the better part of a century to even begin to map. If this video helped you understand the Great Attractor and our place within Laniakea in a way you never had before, take a moment to subscribe, because we are exploring the deepest mysteries of the cosmos every single week, And this is only the beginning of the story. The universe is far stranger and far more interconnected than most people ever realize. Stay curious, stay looking up, and I will see you in the next one.